Hello, my wonderful AP students. This is going to be your Day 18 homework help video. Now, there's also slides of this on the PowerPoint I put up for Day 18. So if you don't want to go through this video, look it up there. But I'm explaining what I'm doing and why I'm doing it for these kind of tough AP questions. Now remember, these AP questions are actually the ones released from the College Board on their practice exam. So this is very similar to the wording and the style of the questions you should experience on forces. So number one, a 50 Newton box. 50 newtons is referring to its weight. So already I'm going to have an arrow down. I'm going to put 50 newtons underneath it to remind me. It's on a horizontal surface. Okay, horizontal. It's in contact with the ground. This is in contact with the ground. There are two forces there. There's going to be a normal force perpendicular, and there's going to be a friction some way. Don't know which way it's going to be, so I'm going to say it's left in this case. I can go back and change it later as you keep reading. The coefficient of static friction, that's when it's not moving. So that's how rough or how smooth the surface is 0.5. The kinetic motion is 0.3. So if this thing is moving, the friction value uses this. That's not the amount of friction, it just helps us find the friction. If it's not moving, our friction value we're going to be using is going to involve the 0.5. A horizontal 20 newtons force is exerted on the box. So if it's at rest, I'm not pushing with the friction. Friction's opposing me wanting to get it to move. That's Newton's first law. So I'm pushing a different direction. 20 newtons. That's my force applied. I call that F1. The magnitude or the amount of the acceleration is going to be what? That's my goal. Now, if it's on a horizontal surface, it's going to move because of my push in this direction. I'm circling these forces, and I'm going to see if there's an imbalance here. I'm going to assume there's an imbalance. If there's not an imbalance, then I will find the acceleration to be 0. I'm also going to circle the y direction, and these are balanced because it's moving horizontally, so there's no up and down motion. I'm then going to make x and y net force equations. In the x, I have the force I'm pushing. I'm going to call this direction positive because I assume the imbalance is to the right. If the imbalance is actually left, I'm going to put a negative acceleration. I'm writing the word imbalance. I'm not going straight to MA because I need to recognize what's happening here, and writing that word will be a definite mental reminder for you. And there's a lot of stuff to keep track of. Imbalance. Newton said that the imbalance is called mass and acceleration. Friction is mu times the normal force, and the force 1 is what we're given. So right here I've created an equation. Now I'm going to solve the acceleration. I'll erase one and put it somewhere else. 20 newtons. If it's at rest, I'm going to use the static coefficient of friction, 0.5. Now the normal force I don't know. Is the normal force equal to the weight here? I don't always say yes. I'm going to make sure. In the y column, I've got the normal force. I'm finding upward is positive, minus the weight, and these are balanced. Newton said that the amount of imbalance for a balance is 0. The normal force I'm trying to find, the weight, which is mg, which is 50. So the normal force minus the weight is 0. This is 50. In the future, since I know they're balanced and these two are the only forces here, they've got to be equal to each other. That is not Newton's third law. Newton's third law is equal and opposite between two different objects. This just so happens to be equal because they are opposite forces in this case. I gotta find mass. Oh, that sucks. Well, the weight is 50. Weight is mass times gravity. Gravity is 10. The mass is 5 kilograms. 20 minus 25 equals 5a. Pause. Here's where the real scientist takes over. The mathematician would say, oh, negative 5 equals 5a. A is negative 1. We're looking at magnitude, so it's got to be positive 1. But that's a wrong thinking. What you should think is, oh, I'm pushing less than friction. So you can't overcome the friction, it's not going to move. And this negative 1 means that the amount of imbalance is this way. Remember, this way is positive. So this negative means that the acceleration is this way. But since it's not moving, that would mean this acceleration speeds it up. But that can't happen because it's friction. So what that means is that that acceleration shows that it can't move, you haven't pushed enough. How much must you push to move it? Some people say 25. I humbly disagree. If you push exactly 25, you will get a perfect balance between these two. Since it's at rest, it will stay at rest. It won't be moving. In order to get it moving, you must overcome it. So you must push a little bit more than 25 to make an acceleration. And with that, in a little bit, we're going to go on to number 2. See you then. And hey, welcome back, my wonderful AP students. It's time for question number 2 and 3. Now again, this is from the AP exam, so let's see what they do with this. In this question, we're actually going to use a little bit of knowledge and do something that's outside of what we're expected to do right now. In other words, we're going to do a question that we can do, 25, and 26 something we're going to be doing a couple of months from now. We got it already. A crate is on a horizontal frictionless surface. Oh, no friction, that's easy. A force is exerted at an angle, causing it to slide to the right. The surface exerts a normal force on the crate. I'm going to draw that in. And that's in the picture. When it slides a distance d, it gains amount of kinetic energy of delta k. What the heck? Well, kinetic means motion, we said. So in other words, you can think of this kinetic energy as like how much speed it increased by. So it's kind of like how fast it went. So it gained some speed. Now, we're keeping the same force, but you're doubling the angle. You can't see that at all. You can't see that at all. You can see that. We're now going to double the angle. Question 25 says, how does a new normal force compare to before? And I'm sure you can probably get this. If we're doubling the angle, before there was a normal force and a part of the force in the y direction. If you double the angle and keep the force the same, there is way more y force than before. So this force is now going to be much bigger. But the y forces are still balanced. If the y force gets bigger, and these are balanced, and this doesn't change, then this force must be smaller as a result to keep it balanced. As a math example, let's say before the weight was 100, making it up. And let's say the normal force was 60 and the y force was 40. If you increase the angle, this will go up. Let's say this goes up from 40 to 70. This is still 100. So these two combined is going to equal 100. And this is now 70. That means this is dropping to 30. Overall, it's still balanced, but the normal force went down. And that's why 25 must be letter B. Now 26, however, pause. I'm sorry about that. We had a wonderful interruption from Mr. Skeels over here. Say hi to the wonderful people.
How you guys doing? Hope everyone's doing well.
I hope so too. So, back over here. Question number 26 says, as the crate slides, how does the gain in kinetic energy compare to before? Or in other words, how does its speed compare to before? So if you increase the angle, you have a lot more y velocity. Whoa, that's horrible. Let's try that again. If you increase the angle, you have a lot more y force. You're losing forward force. Because as the angle gets bigger and bigger, the x part gets less and less. So now, the x part of before is now going to be much smaller than it was. And since there's no friction, this is the force driving it forward. So if you have less forward force, you don't gain as much acceleration, which means you don't gain as much speed. So the gain of speed is going to be less than it was before, which is going to be letter B. As a quick summary, when you increase the angle by pulling it up, the bigger up force of your pull decreases the normal force. The bigger up force of your pull results in a smaller forward force, which results in less forward acceleration. I'll see you for number 3. Welcome back. We're doing the back 3 now. We already did number 40 in class, which we had as always answer A because Newton's third law. Let's look at 41. Assume it's moving at a constant speed. Okay, constant speed. Is that a balance or an imbalance then? Nice job. Definitely balanced. So I'm going to circle, I'm going to put B there because it's moving at a constant velocity. The bottom box is 2m and the top box is 2m. We're going to draw the forces on the bottom box. Okay. Question. How many things is the bottom box in contact with? 2. It's talking about the ground. The ground has got to push up, called the normal force. And it's also in contact with this box. Which way is this box pushing on this box? Down, of course. And they say to call this F box. There's no friction here, so there's no left and right things. Cool. Now there's always one force that does not have to be in contact, and that's called weight. So the question asks, which of the following is a free body diagram for it? And we have it. This would be letter C. Again, because this is in contact with 2 things. The ground pushing it up, and this surface pushing it perpendicular, which is down. I'll see you in for number 42. My, how time flies. We are now going to do the last question, number 42. Notice how 40, 41, and 42 are 3 questions all revolving around this idea of forces, Newton's laws. 3 questions on a 60 or 70 question multiple choice exam, all in the same situation. This is how I'm going to get you prepared for it. Number 42 says, assume upward acceleration. I saw the word acceleration in there. Immediately that should say imbalance to you. And there are 2 boxes of mass M. We're now looking at the top box. Wait, hold on. What is the force on the top box by the bottom? So we're looking at the top box. Now, how many things is it touching? The top box is touching just one thing. The bottom box. It is not touching the elevator. It's only in contact with the box. Which way is this box pushing on the top? Up. I'm going to call that F box. And I'm trying to find that too. There's one force that's always pulling, even on contact, and that's weight. Are these 2 forces balanced or imbalanced? And the answer is they are imbalanced because this is accelerating upwards. So I'm going to write I, imbalance, and up here I'm going to write it because this is the bigger one. It's moving up. I'm going to call this direction positive. Okay, let's write down our things. In the y direction, the force of the box minus weight, positive, negative, is an imbalance. Newton said that imbalance is represented by a mass times acceleration. The weight is represented by a mass times gravity. And the force of the box is what we're trying to find. Let's move this over. MA plus MG. And then we take an M, factor it. Congrats, we just solved for letter D. So what was required in this? You had to understand that the box push was up. There was not a normal force. And the way you would do this is by always asking, what is it in contact with? And then drawing a picture for that situation. You can definitely do this. It just takes some new wording. With that, ladies and gentlemen, have yourself a good day.